Central limit theorem. Central limit theorem states that if a random sample of size n is drawn from a population with mean and variance, and n is chosen large enough, then the sampling distribution of the sample mean is approximately normally distributed, with mean, sample mean is equal to the population mean, and variance is sample variance is equal to population variance divided by n, or sample standard deviation is equal to population standard deviation over n. This theorem says that regardless of the distribution of the population, whether normal or not, from which the sample is taken, we can choose a sufficiently large n so that resulting sampling distribution of the sample mean will approach a normal distribution. In general, n is greater than or equal to 30 is large enough for sampling distribution of the mean to be approximately normal. Example: suppose that the sample of size n is equal to 100 is taken from a population with mean 500 and standard deviation 80. Find the probability that the sample mean lies in the interval 490 and 510. For the solution, since the sample size is 100 and it is large enough, which falls in n is greater than or equal to 30, we can apply central limit theorem and assume that the sampling distribution of the mean is normally distributed. So we have sample mean is equal to population mean, which is also equal to 500. And then sample standard deviation is equal to population standard deviation over square root of n, and that is 80 over square root of 100, which is equal to 8. Now, if x bar is 490, then the counterpart or the z-score of that using this formula is negative 1.25. If x bar is 510, then the z-score of that is 1.25, positive. We wish to find the probability that the sample mean is between 490 and 510, or the z-score is between negative 1.25 and 1.25. Now, using our link or what we call the normal curve graph generator, so plugging in 1.25, and then we have this interval negative x to x, the result is 0.7887. So the probability that z is between negative 1.25 and 1.25 is equal to 0.7887. This shows that 79% of all the sample means will fall between 490 and 510.